All right, we are moving on to chapter 12. Every quadratic equation, when graphed, has this U shape, and it's called a parabola. And a parabola has a lot of really cool geometric properties, which we're not going to talk about today. But the places where the graph crosses the x-axis are called the roots, or the zeros, or the solutions, or the x-intercepts. 4 different ways to name that. And then we have a y-intercept and some other things. So this one asks, does the parabola open upwards or downwards? Downwards. This is a sad face parabola, as opposed to a happy face parabola. So that would be downwards. The point at the peak or at the bottom of the trough is called the vertex. So in this case, the equation of the vertex, or the point of the vertex, is -4, 1. Okay. If I were to draw a line down the middle of the parabola and cut it into 2 equal pieces, 2 symmetric pieces, that line is called the axis of symmetry. Okay, and the axis of symmetry is, in this case, x equals -4. So the equation of that line is x equals -4. If the parabola is a horizontal parabola, then your axis of symmetry would be a y equals, but I don't think you're going to see that today. All right. And what are the x-intercepts and what are the y-intercepts? So in this case, the x-intercepts are -6 and -2, and the y-intercept would be -3. Piece of cake. All right. Domain and range. So the domain, oh my goodness. The domain is all x values, and the range is all y values. So does x equals -3 exist on the graph? And if I go up here, yes, it exists right there. Does x equals 2 exist? It does. We can't see it, but this is going to continue forever. So if I go up high enough, I will find a point where x equals 2. What about x equals -10? Yes. So the domain of this is all real numbers. And anyway, you would just put the all reals value in there. Okay, what about the y's? Does y equals 8 exist? Yes, there and there. Does y equals 4 exist? Yes, there and there. Does y equal 2 exist? Yes, right there. Does y equals 1 exist? No. There is no graph at y equals 1. So in inequality form, the range would be y is greater than 2, but is it equal to? And the answer is it's always equal to unless they tell you it's not. So this would be y is greater than or equal to 2. All right. How does it want me to graph this? Okay. All right, well, to graph this, we're going to have to find, I'm going to see if I can bump this into the next equation, because they don't give me access. Oh, maybe they do. Do they give me access to the graphing calculator? No. Okay. I'm going to try to bump this into the next section. All right, here we want to graph with the graphing calculator. So I turn on the graphing calculator, and I go into y equals, and then I type the function. It's in the way. Okay. Oh my goodness, go away. Looks like I need to do this from my computer. All right. So negative 3x raised to the second, and then I need to push right, plus 2x plus 3. And I click graph. So the vertex is right here. And I could guess to see what the numbers are, but I'm going to say calculate. Nope. Extrema. Okay. So we want to find the extrema. And extrema means the highest and the lowest value. And I just need to draw these lines so that they capture this value. So I'll say from 0 to 1. Is my answer between those two blue lines? Yes. Find extrema. And the minimum doesn't really make any sense in this case, but the maximum is 1/3, 3 1/3. So the vertex is 0.33, and the y is 3.33. And then the x-intercepts. So if I go to graph, and I find the zeros, so it wants to know where do you want me to look. So I'm going to look between -2 and 2. Wonder if it will find all of them. Let's see. I freaked out. Zeros. So -2 and 2. Okay, it will only find one at a time. So let's do -2 to 0. There's one of them. And then let's look from 0 to 2. And there's the other one. Okay. All right, so graphing calculator. So 2x squared minus 10x plus 7. Oh, dang it. 2x squared minus 10x plus 7. Graph. And then I want zeros. So the first 0 is between 0 and 2. There's my answer. And the next 0 is between 4 and 5. And there it is. All right. That is it for today. Get to work.